All right, so question number 47. A college student has 2 different jobs. Her combined work schedules consist of no more than 40 hours in 1 week. We want to know which graph best represents the solution for all of the possible combinations of X and the number of job hours she worked at her first job and Y the number of hours she worked at her second job in 1 week. Okay, so there's a couple of ways that I can look at this. So that means her second job is Y, her number of hours is X. So I want to pay attention to the number 48 that's on the graph, okay? And I can kind of reason this through just by looking at our numbers. Notice if I look at C, this has an arrow going and the shaded region is past 48. It goes off, and that arrow means it goes off into infinity. So C is going to be out automatically because it's going past that value. Okay, A looks really good, a really good candidate for me. B is not going to work because it's above the area. If we're talking about the number of hours, we're looking at the number of hours below the line of the graph. So B is going to be out. And same situation as D. So by default, our answer has to be A. And it is A, just if you think about it, if we talk about our region, she can work anywhere between 0 and 48 at her first job and 0 and 48 at her second job. All right. Number 48, which is equivalent to which function. So that means we're putting it, if I look at my answer choices, they are in factored form. Okay, so I want to see, there's a couple things that I notice here. One thing I noticed that this term here is a perfect square. I also know that this is a perfect square. And if I understand the rules of perfect squares, that probably tells me that this is actually 3x minus 16 and it's squared. So it's telling me that this, I think that that's my answer, number J. The reason I'd say the minus versus G is because this is a negative here and this is positive, but let's check. So that means 3x minus 16 times 3x minus 16. This is what we call a perfect square trinomial. So the sum of these two numbers would end up giving me the middle term. Okay, so 3 times 3 gives me 9x squared. 3x times 16, 3 times 16 is going to give me negative 48x. And then 16 times 3 is going to give me negative, oh, this actually might not work, because 3 times 16 gives me 48, and then 3, that's going to give me minus 48x. Then that would give me plus, oh, wait, hold on, I know what I did wrong. That should be 4, not 16. This should be 4. There we go. Now it's going to work. Okay, so 3 times, that's going to give me 12x. This is going to be negative 12x. This is going to give me plus 16. 9x squared minus 24x combined like terms. That gives me plus 16. That matches our original polynomial. So yep, we did that right. That's what we call a perfect square trinomial. That's one of those special quadratic equations. Number 49, which of these best represents the system of equations and its solutions? So if we're looking at graphing, we want to solve both of these for slope-intercept form. So I'm going to put this is going to become negative 4y is equal to negative 8x minus 16 divided by negative 4. This is going to give me y is equal to positive 2x plus 4. Okay, so let's see if I can eliminate anything off the bat. So one of my equations has a y-intercept of plus 4. A is out. C is out. B looks promising. It's got an intercept there. D, no y-intercept of 4, so D is out. By elimination, it has to be B. But we can go ahead and finish and let's double check. So let's do our second equation. So that's going to be 15y is equal to negative 3x minus 6 divided by 15. That's going to give me y is equal to negative 1 fifth x, and then minus 1 divided by, or 6 divided by 15. It's going to give me 2. Give me 2/5. So let's see. That means the second equation should have a slope of 1/5. Down 1, 2, 3, 4. It does. So we are good with both of these graphs. Okay, and the y-intercept is right there. It's not a nice number, but our y-intercept on our equation is not a nice number either. All right, question number 50. We've got this function here, the domain and range. It's a function. Domain and range of these are going to be, domain's going to be all real numbers. So it's going to eliminate G, and it's going to eliminate J. Why is it saying? Oh, because it's squared. Hold on. So we need to go ahead and solve. Yes, so we want to look at our vertex. So our vertex is going to be this. This is our H. This is our K. So this is our H. This is the K. This is our quadratic. So our domain is going to be all real numbers. All quadratic functions, domain is all real numbers. So that gives us our answer choice F or H. Now, my vertex is at the coordinate point 1761. So the y value is 61, and this is a sad parabola, so that means we're dealing with a maximum. So the y value has to be less than or equal to 61, which is our answer choice F. I'm going to go ahead and start on number 51 in the next video. I will see you then.